Hey everybody, in this lesson we're going to talk about hypothesis versus theories versus law and how we classify matter. So there's two big ideas here. Hypothesis is an unproven statement, but a set of hypotheses that comes from real world observation is a theory, as it has been repeatedly tested and accepted. The other big idea here is that we can classify matter into its various categories. So what is the difference between a qualitative and a quantitative property? So the big thing is we need to know how to classify matter first of all based on its property. But what are the two different ways to classify properties? It's qualitative and quantitative. Qualitative comes from the word quality, which means it is a non-numerical property. It's the one where you use five senses. So what do you see? What color is it? What does it smell like? What does it feel like, for example? Quantitative comes from the word quantity. Quantitative means it's the numerical property. So it's the one that deals with number. So an example of that would be if I talk about qualitative, I could say let's explain like your computer. A non-numerical could be that it is plastic, it's gray, it's white, it's red, it's blue, whatever it is. It has rounded edges, for example. Quantitative could be it has 100 keys on its keyboard. It has one touchpad. It has one monitor. It has two speakers, for example. So there's many ways we could talk about these type of properties. How does that relate to data and observation, or some people call it data and observation? So in this case, data is mostly quantitative information. Okay, it's quantitative information. Anything that has numbers or whatever, that's data. That's collected. Well, observation is usually seen as your qualitative information. Now, whenever you deal with data, you usually want to put these in tables or graphs because that keeps the data a lot more neat. It's a lot easier to read. What we're going to go into now is what are the differences between hypothesis, theory, and law? Well, let's start with hypothesis. You might remember writing hypothesis a lot in elementary school. Your teacher goes, "What do you think will happen?" And you will scream, "It will explode." But that's not really what a hypothesis is. A hypothesis can be that, but not always. A hypothesis is a statement that is to be tested. Okay? So you might call it an educated guess. Compare that to a theory. Now, you might have heard a lot of different types of theories: the theory of evolution, theory of gravity, theory of relativity, right? Those are all theories. A lot of people think theories aren't true, but that's not correct. A theory is, in a sense, tested. It comes from observation. It's a set of hypotheses that has been tested and observed in the world. So it has to have been tested and observed for a theory to be happening. That's why it could be considered true in a sense. The last one is a law. A law is basically will state the result of an experiment under specific situations. So there are different types of laws. A lot of laws come with formulas, for example, such as, for example, Boyle's law, which relates pressure and volume. So laws are that. So hypotheses is just a statement that is to be tested. A theory is a set of hypotheses that has been tested, observed in the world, And a law it states the result of experiment under specific situations. What we're going to move on to now is we're going to talk about matter. How do we classify matter? So as you see here, matter is, well, it's very important that we know what it is because matter is anything with mass and volume. If something has mass and it takes up some space, it will be considered matter. Mass is the amount of matter in a substance, while volume is the amount of space a substance takes up. Now, usually I tell this joke to my class in which that you have mass and you have volume, thus you matter. But it's as corny of a joke as I could tell, but I usually get a few laughs. So we're going to go into now, what is a substance? Okay. A substance is defined as something with a unique set of properties. What that means is two substances may look the same, but have, for example, different melting points. Like, for example, this would be, for example, nickel and silver may look alike, but they may have different properties. That's why nickel and silver are different substances. Okay. What is a physical property then? A physical property is anything that in which when you observe it, it won't change the substance. And change. And not change the substance. Now we classify these in two different categories. Physical properties can be either intensive, and intensive means amount of how much you have that substance does not affect this property. Does not matter in a sense. So what is a property that in which if you have a little bit of it and a lot of it, it does not change its property? Color. Color is an example of one, because if you have red brick and a lot of red bricks, they're still both going to be red. Density doesn't change. Melting point doesn't change. So those are examples of intensive properties. The opposite is called extensive, where amount does matter. So for example, volume. If you have a lot or a little, it'll take up different amount of spaces. The mass of it, because if you have a lot, the mass will change. So of course there's many different types of properties, but these are examples of some of the physical properties. Compare that to a chemical property. A chemical property is a property of a substance that undergoes a reaction. So for example, if you talk about, let's say, hydrogen. hydrogen's chemical property when it burns or when it reacts with oxygen will create water. So that's an example of hydrogen's chemical property. That when it, for example, combusts, it will create water. Now, what we're going to go into next is what are states of matter and what are their properties? Well, let's take a look. We have 3 states of matter. We actually have 5, but in this case, we're going to talk about the 3 that we know. We have solids. Solids they're very ordered. Not only very ordered, they cannot be compressed. You cannot compress a solid because they're very close together. They can only vibrate. And also they have defined shape and volume. Okay, so that's solids. So if you look at this diagram here, that's an example of a solid. It is very defined and in shape and volume. Okay, liquids. Liquids will slide past each other. But they still cannot compress. You cannot compress a liquid. That's why if you ever get water in, for example, a car's engine, it can actually destroy that car's engine. What liquids also have is that they have defined volume. So the volume of a liquid won't change, but they will take the shape of the container. There's a very famous quote by Bruce Lee which talks about if you put water in a cup, it becomes a cup. You put water in a teapot, it becomes a teapot, and so forth. It's a philosophical quote. If you have time, you can YouTube it. But liquids will take the shape of the container that's in. Alright? The last one we're going to talk about is gas. Gases fly by each other. They're very far apart, and they can be compressed now. So gases can be compressible. Okay, but what they do is they will now have shape and volume of container. So a gas will take up the full shape and volume of the container. You might think of it in terms of osmosis, right, or diffusion. A gas will diffuse itself amongst this container. Like, say for example, if someone was to peel an orange, the smell of that orange will go around the whole classroom. Now, of course, are there any other states? Yes, there are. There's 2 more types of states that we have that are pretty common, and they are, and first one is plasma. Plasma is a gas made up of charged particles. It's where you rip the electron off of that particle and it becomes charged. So for example, lightning. Lightning is a plasma. The next one is called superfluid. Superfluids are, for example, liquid helium. They have no friction. So because they have no friction, they can actually move forever. So the last thing we're going to talk about is how do we classify matter? We classify matter based on these different terms. The first term we're going to talk about is element. An element is the simplest substance. That means you cannot break it down anymore. So for example, silver, copper, oxygen gas. These are elements because they're the simplest substance. They cannot be broken down anymore. Cannot break down anymore. So you cannot break them down anymore into simpler substances. Atoms, though, are the smallest possible unit of an element. So for example, oxygen gas is an element, But oxygen gas is O2. There's two oxygens. That one single oxygen is an atom of oxygen. So oxygen gas, an element, is made up of two atoms. Okay. Then we also have molecules. Molecules are defined as two or more atoms bonded together. So an example of that would be like water. Water is a molecule. CO2 is a molecule. Okay, so those are examples of molecules. An ion. An ion is a charged particle. A charged particle. A molecule or an element can be a charged particle. So an example would be like sodium ion. The last one is what we call a compound. So I'll write over here. A compound is a molecule made up of multiple elements. So an example would be NaCl. NaCl, sodium chloride table salt, is made up of sodium and chlorine atoms. So this table here can actually tell you how you classify matter. So we're looking at more on this side right now. Okay, where you have pure substances, can be broken into elements and compounds. Elements are composed of the same atoms. Compounds are composed of different atoms. An example of elements are gold, iron, and oxygen. Example of compounds are water and salt, for example. We're going to go to this side in our next lesson when we talk about different types of mixtures. But we have two different types of mixtures. We call it homogeneous and heterogeneous. And all mixtures are made up of solvents and solutes. Okay? And so we're going to talk about that. Or not all mixtures. Ooh, my bad. All solutions are made up of solvents and solutes. Alright? So, as always, make sure you keep yourself safe and healthy, and I'll see you soon.